Raina's been this is from AMD. Raina's been working for more than 30 years on ASIC design, the last 10 in verification. He currently leads the video core verification in AMD's Cambridge office. Swarav has 18 years of experience in ASIC SoC verification. He currently works at AMD Cambridge in the data center group, both from AMD, and the title of the talk is Finishing Coverage Closure in a Controlled Way. Over to you, Raina.
Is it on? Oh, yes, it is. So thanks, Mike, for the introduction. So it was so lengthy. So let's move on. Does it look?
Should we just get the phone?
The right, left. This one. Okay. So what are we talking about? The problem is that I want to talk a bit about coverage closure, and the purpose of coverage closure is obviously to allow a risk assessment. Are we done? Can we tape out? But the problem you usually have is that the coverage numbers are not reflecting really well what is the remaining risk until we have hit 100% coverage. The reason for that is that the risk doesn't go down proportionally with the increase in the coverage numbers, because the risk is actually hidden in the things you haven't covered yet. And in order to hit the 100%, the last few percent take very long to close. And what happens is, if you concentrate too much on the coverage numbers themselves, so you run the risk that verification engineers are usually clever people. They go for the low-hanging fruit. Do I really close the missing FSM state, the missing functional coverage bin, and hit one item out of my 13,000 something missing ones? Or do I look at those really wide buses where the total coverage is not bad? Oh, I write something and look, hey, the number jumped up 0.5% because I covered so many, but did your risk actually go down? Not really. You end up with something like in that red curve, your coverage increases and increases and increases, but your risk flattens out, and towards the end, suddenly you find out, oh, there are some big risks left. Now we have to panic and try to fix that. And that is a problem, because in real life, RTL is frozen before you hit 100% coverage. I haven't worked for a company which says, yes, that's fine, Rainer, take all the time you need to hit your 100%. We hold the whole tape out up until you have done. They say, it needs to be done. What is risk? Give me an assessment. Where are we? So we need somehow to classify the remaining coverage holes in a meaningful way. And what we are suggesting is to use classified waivers to analyze the remaining holes. Why using waivers? It's quite simple answer. Using the waivers ensures that we don't miss holes, because you know what we have already analyzed and what is still not analyzed. Obviously, because that waiving is a time-consuming process and takes a lot of resources, you should wait before you start the waiving until you have run enough tests to see your coverage isn't increasing anymore, and definitely you should have run some kind of unreachability analysis tool. If you don't use unreachability analysis tools, you're just wasting engineers' time. But if we classify our outstanding holes, then we know we can pick up the issues with the highest risk first, and then work slowly down to less and less risky issues. That has advantage. We can distribute the work, and the other thing, you can give your manager simple feedback. How much is the remaining risk? Because if you just tell them, oh yes, we still have 1.3% missing coverage, what does it mean realistically? And what the suggestion is to use a waiver classification scheme using a traffic light. Traffic lights are straightforward. Everybody uses traffic light schemes. It's easy to understand. And so the different categories you put your risks into is, you say, a red waiver. That means it's completely untested. Please, marketing, go out and say, yeah, we can do that. No, we don't know. We haven't tested it. Amber means, okay, It works most of the time. There might be some corner cases we can't hit. For a code freeze with red ones, as a verification engineer, I would definitely say, no, we are not taping that out. We are not there yet. For amber one, I would say, yeah, we can go, but please understand we run the risk we might need some ECOs after the code freeze. Having said, as a verification engineer with a red one, I would say, no, we are not going out. Management might decide, yes, we go out. They might argue and say, well, that is actually something the current user doesn't care about. We look at that later. So from a verification point of view, you would say, okay, that's fine, tape it out with that, with understanding it isn't working. But you know, you have to fix that first before you move on to the next project to make your design fit for reuse. And then we still have some green waivers. Those waivers obviously don't have an impact on the code freeze. And basically, it only means there is some reason why your UNR hasn't hit that. Could be a tool bug, could be really complicated things where UNR is currently struggling. And now I'm moving pretty fast, sorry. But so here at the end, some hints how you could do the waiver classification. Obviously, it's only hints. It really depends on the type of design and on the verification requirements you have. Is it a gaming console where you have a red spot in one frame which disappears? That is fine. You probably get away. Is it a self-driving car? Then you should get really concerned. But the lines along is, I would say, a red waiver is always to be applied. If you have some code you can't execute and UNR hasn't found that, that is really something you should be concerned about. Then expression coverage, which means was each of your conditions at least once true and once false. There are some tools out which can actually merge that together in some implicit else. Toggle coverage 0%. You have a signal which never ever wiggled. Not a single bit of your bus. There is also something you should be concerned about. FSM states missing functional coverage pins. The amber ones are the next step, which basically say, okay, if we have wiggled some bits in our signals, but not all of them. I don't have 100% expression coverage, so I have not gone through all the permutations to make it true or false, but at least I did hit some FSM transitions. Functional cross coverage bin would also go down into the same category. And green ones are the ones you say, we shouldn't really have them, but mainly it boils down to, it is too complex for UNR. I found a tool bug where you have to find a ticket. The last thing I should say with that is when you look at that classification, that is only the first step for the triaging. So a red waiver might get converted into a green one after you have analyzed it and said, well, yeah, it's really, I can't hit that for whatever reason. Therefore, I waive that. But it gives you a good idea, and also it gives the management a very simple to understand feedback. If you say, well, yeah, we don't have any red waivers there, so we are most likely happy to go ahead, or now our IP is completely done. We have only green waivers left. That was it from my side. Now I hand over to my colleague.
Hello. So originally Sora was supposed to present that, but due to some emergencies, he couldn't come here today, so I'll be cover for him today. So the topic will be similar to my colleague's presentation. That will be crossing coverage merging. I guess most of us here experience coverage mergings and some of the issues that it's coming with. I will present some of the issues that we were facing and how we solved them. So speaking of verification of HDL, the same HDL or similar is usually spread or feed to different teams at different levels. We can have small, from the lower level, we can have unit verification. That means either single IPs or single modules have their own verification environments. Then we go a bit higher to the subsystem verifications. We got chip verification, emulation, and hardware-software COSIM. Now, each of those teams or groups perform their own coverage analysis, and obviously they come with different coverage database. So how can we improve this process of coverage analysis for each of the group? And also, how can we improve the coverage closure for a project? That's one of the most important processes for all of the projects finish. What we can do is we can merge some of those database, maybe not all of them in once, but we can merge some of them, and we can call it a union. So we can merge different cover database from different teams to help each of the teams to reach their coverage goals. The question here is that always possible? It might be possible, but it's never easy. So there are many issues. Let's start with just the basic one, which is the HDL. So the different teams share HDL, but the version of this HDL might be different. For example, unit level uses newer version, chip level using older versions. Then we have hierarchies. So on the chip level or top level, we got the higher hierarchy. We go down to the block level, that's different. Then emulation may have different hierarchy as well. The one more issue, and one of the biggest one, and that's what I want to present today, is actually the tools. So some of the teams here using different vendors than others. For example, emulation may be done by EDA from one vendor, and chip level or subsystem is using different vendor. That means that just a simple cover merge comment will not work in this case. So what we do, we came up with a simple solution with exclusions. So let's focus on two cover database. So let's say we have one cover database from one vendor and another coverage database from second vendor. We came up with the script that helps with merging. So how it works, first we need to generate the reports. All of the tools or all of the vendors allowed to do that. We generate the coverage report with annotations. Then our script is generating the base hierarchy instance map. And from that, it analyzes each of the items in this report and generate exclusion in a form that the other tool or the other vendor can understand. In that way, we can apply those exclusions to the target coverage database, and basically we can achieve a merge of two databases. That sounds pretty easy, but trust me, it's not. And there are a few issues that we experienced. One of them was that each of the vendors have different understanding of the source code. The items it generates in a coverage is different. So the itemization is different. Then the whole report is different as well. So the script we created that analyzes the script is completely, the way it analyzes the scripts is different from tool to tool. And then also the annotations for source code is different. What it means is that's one of the biggest downsides or disadvantages of the workflow we did, is that for each of those coverage databases we're merging that coming from different vendors, we need to create another set of scripts. Yes, so it only works for two sets of vendors. So what we did, we currently implemented that for Toggle, for Line, and for FSMs. It works fine. The future enhancement is still work in progress. So the future enhancements is branch, condition, and expressions. We also thinking about functional coverage. So yeah, that's work in progress. So the summary here is that merging coverage of various database can be really, really helpful to receive the time to market and the project closure. The difficult here is that there is no simple merge flow solution, and there are some difficulties that we face during the exclusions. But we are on a verification futures conference, so there is some future. There is a solution to all of that, and that's called UCIS. So Accelera came up already with the standard, but unfortunately, it's not followed by all of the tools. So if that will be applied to all of the vendors, then yeah, basically this issue wouldn't exist. Yes, so that's the issue. Okay, so that's all in terms of that. But I have some good news at the end, and that's a big announcement. AMD is hiring in the UK. So to anyone that might be interested, we have offices in Edinburgh, Cambridge, and Bristol. Our roles involve obviously verification, design, emulation, compilers, and design. We do CPUs, we do Radeon GPUs, and we do smart NICs, as well as video. If you are interested, just please follow us either on LinkedIn or our website. Thank you for your attention. Are there any questions?
Any questions apart from applications? Any questions from you? No? Thank you very much. I will.